Thermodynamics is a branch of physics that deals with the concepts of heat and temperature and the interconversion of heat and the other forms of energy. Diathermic wall is nothing but a conducting wall. Adiabatic is insulating wall. Diathermic is a conducting wall that allows the heat energy to flow from one system to another system. Until the temperature in all three systems becomes constant, there will be an exchange of heat between these three systems. So this is the explanation of zeroth law of thermodynamics. Hello everyone. Welcome to first session of Chapter 12 Thermodynamics. This is Swati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. Till previous session, we have come across the topics about thermal properties of matter. In this chapter, we are going to study about the transfer of heat into an energy. How does the heat and energy can be interconverted? So let us now begin with the introduction. What is thermodynamics? What thermodynamics means? So thermodynamics is a branch of physics that deals with the concepts of heat and temperature and the interconversion of heat and the other forms of energy. See, as we do like this, the way as we rub our hands, what do? Here the mechanical work we are doing and there will be a formation of heat. Say for example, in thermodynamics, we are going to study about the heat and temperature concepts, and also we are going to understand how does the heat can be converted into other forms, the interconversion of heat and the other forms of energy. So that is basically thermodynamics. It is a branch of physics which deals with the study of heat and the exchange of heat into other forms of energy. In the understanding of thermodynamics, we must know about certain variables, certain terms, one of which important term is thermodynamic system. So what is the meaning of thermodynamic system? Why the name thermodynamic system? So it's very important to know about this because we oftenly use this word in the study of thermodynamics. So a collection of an extremely large number of atoms or molecules that is confined within certain boundaries, and it has certain values of pressure, volume and temperature, and we'll call it as thermodynamic system. Basically, a thermodynamic system or a system means it's a part of universe which is under our observation. Here, thermodynamic system is nothing but a collection of extremely large number of atoms or molecules which is confined within certain boundaries, and it has got the values of pressure, volume and temperature, and that system we'll call it as thermodynamic system, which means we are observing a system which is confined of a number of atoms and molecules which has got the values of pressure, volume and temperature, and we will call it as thermodynamic system. Apart from this system, the rest of the things which is around the system will call it as surroundings. So anything outside the thermodynamic system to which energy or the matter is getting exchanged, we'll call it as surroundings. So it's so important to know about these terminologies, thermodynamic system and surroundings. And next we have thermodynamic variables. So as we all know, variable means something which is not constant, something which is changing always. What is the meaning of thermodynamic variable? So thermodynamic system can be described by specifying its pressure, volume, temperature, internal energy and also the number of molecules, etc. And these parameters which are not constant and they will be changing with time, and these parameters or variables are called as thermodynamic variables. So next we have thermodynamic process. The terms which I am explaining are very important to understand the concepts of thermodynamics. So next concept is thermodynamic process. What is the meaning of this? So it's a process in which there is a change in thermodynamic variable. When there is a change in thermodynamic variable, so next we have thermodynamic equilibrium. So the term equilibrium means stable. So thermodynamic equilibrium, what is the meaning of that? So if the system is in thermodynamic equilibrium, it has to satisfy these three conditions, which means the system must be in thermal equilibrium, it must be in mechanical equilibrium, it must also be in a chemical equilibrium. What is the meaning of thermal equilibrium then? So thermal is the word which suggests or which refers to the concept of heat or temperature. So a system is said to be in thermodynamic equilibrium if the macroscopic variables like volume, temperature, pressure, these are the variables that characterizes the system. It should not change with time. It should be a stable thing. So if the system is in thermodynamic variable, it should satisfy all these three as I said. And the concept of thermal equilibrium means in the system the temperature remains constant and hence the condition is nothing but the thermal equilibrium condition. And mechanical equilibrium means there should not be any external unbalanced force in a system. If there is no unbalanced force, then we will say it in a mechanical equilibrium condition. And chemical equilibrium means there must not be any chemical changes inside the system because of the external agencies. So if all these things remains constant, all these three conditions satisfies in a system, then we will say the system is in thermodynamic equilibrium condition. So next we have adiabatic wall. Here it is very important, there is a note, a very important thing to understand the walls. So one is adiabatic wall and the other one is diathermic wall. Adiabatic is a word we again oftenly use in this chapter. We must understand what is the meaning of adiabatic wall. So adiabatic wall is an insulating wall. So what is the meaning of insulating wall? Insulating wall means it does not allow the heat energy to exchange between the system and surrounding. So which does not allow the energy or the matter, the heat energy to pass from one system to another system. Because it is insulating, there will be no exchange of heat from one system to another system, and this wall is called as adiabatic wall. So next we have diathermic wall. Diathermic wall is nothing but a conducting wall. Adiabatic is insulating wall, diathermic is a conducting wall that allows the heat energy to flow from one system to another system. So these are certain basic concepts in the introduction or the foundation to understand the concept of thermodynamics. Now let us move on to the first topic under thermodynamic chapter, that is zeroth law of thermodynamics. It is very important to understand the laws of thermodynamics. It has also got some practical applications. The laws of thermodynamics helps us to understand the basics of nature. So zeroth law of thermodynamics is our next concept. The law states that if two systems separately in thermal equilibrium with the third system, then the two systems are thermal equilibrium with each other. Statement is saying that if any two systems are in thermal equilibrium with the third system separately, then indirectly the first two systems will also be in thermal equilibrium with each other. So how to understand this? Let us go through the explanation. Here you can see there is an adiabatic wall between a system A and system B. So since it is adiabatic wall, this is insulating. So there will be no exchange of heat energy between these two systems. But here we can observe there is a diathermic wall, means this is a conducting wall. Since it is a conducting wall, the heat energy will be exchanged between these two systems, and here also the heat energy will be exchanged between these two systems. Since the third system, this is the third system which is connected to system A and system B, there will be an exchange of heat energy between all three, and the temperature will attain equilibrium condition in all the three systems, and hence we can also say that A and B also are in thermal equilibrium condition. So this is the explanation for zeroth law of thermodynamics, which says that imagine two systems, system A and system B. I have two systems and they are separated by an adiabatic wall. You can observe here they are separated by adiabatic wall, and now they are in contact with system C and they are separated by a diathermic wall. So the macroscopic variables of A and B tend to exchange their temperature, but until what condition the temperature will exchange between these two systems? Until both of the systems, that is is A and B, come to a thermal equilibrium with C, which means until the temperature in all three systems becomes constant, there will be an exchange of heat between these three systems. So this is the explanation of zeroth law of thermodynamics. Also, we can write an expression for this. Say, for example, for system A, the temperature I will take it as TA, and for system B, I will take it as TB, and for system C, I will take it as TC. Then, according to zeroth law of thermodynamics, we know that the temperature in the system A, which is equal to temperature of system C, since they are in contact directly with each other, as well as we can write temperature of system B, which will be equal to temperature of system C, though A and B are not in contact directly with each other, but according to zeroth law of thermodynamics, the condition, that is temperature of A, will also be equal to temperature of system B, because the heat energy will be exchanged within all these three systems since they are separately in contact with the third system C. Now, what is the significance of zeroth law of thermodynamics? What concept that we come to know about in the study of zeroth law of thermodynamics? So, it clearly suggests that when two systems A and B are in thermal equilibrium, there must be a physical quantity that has the same value for both. Then what is that physical quantity? That physical quantity is nothing but temperature. So, if when two systems are in thermal equilibrium, temperature is the physical quantity that remains constant between them. So, hence we will come to know about the concept of temperature in the study of zeroth law of thermodynamics. So, our next important term is internal energy. What is the meaning of internal energy? It is nothing but the sum of kinetic energy and potential energy of all the molecules of the system. So, in a system, we know that there are extremely large number of molecules or atoms that will be confined within the boundaries. So, all these atoms or the molecules will be having a kinetic energy as well as a potential energy. So, if you take the sum of these two, we'll get a quantity called as internal energy. So, internal energy is denoted by capital U. So, it is given by the expression U is equal to KE, that is kinetic energy plus potential energy. Increase in internal energy of a system is considered as positive. The sign convention is very important in the study of thermodynamics. So, if the internal energy increase, then the sign will consider as positive, and decrease in internal energy of a system is considered as negative. So, this is very helpful in solving numericals. This is very important to understand. So, next, internal energy of a system can be increased by two ways. We can increase the internal energy of a system. There are two important ways to increase the internal energy: by supplying heat energy to the gas by maintaining a temperature difference between the system and the surrounding. If you continuously supply heat energy to a gas and there is a temperature difference between the system and surrounding, because of the heat energy what we supply, speed of the gas molecules will be high and hence their kinetic energy will be more. So, sum of kinetic energy and potential energy will be equal to internal energy. So, we can also increase the internal energy by just supplying a heat energy, and if there is any temperature difference between system and surrounding, then the internal energy of the gas can be increased. And also by doing work on the system, by compressing the gas in the system, we can do any external work on the system to increase the internal energy. So, these are the two ways internal energy can be increased in a system. So, next important term in thermodynamics is work done. So, what is a work done? When the work is said to be done, if a body or a system moves through a certain distance in the direction of applied force. So, when we apply some force, we can see the change in position of an object, which means it is undergoing displacement. So, force into displacement gives us work done, and we can write it as force into displacement. Expression wise, if we write that, we will get dW is equal to force is nothing but P into A, because we know pressure is equal to force divided by area. Force is equal to P into A into displacement is dx, and we can write A into dx is nothing but area into a small length travelled, so it is nothing but delta V. So P into delta V. There is a sign convention. The role of sign convention is important again in this topic. So work done by the system is taken as positive, work done on the system is considered as negative. Let us move on to the next very important topic, that is first law of thermodynamics. We have studied about zeroth law of thermodynamics, the significance that we came to know about the concept of temperature in zeroth law of thermodynamics. Now, what is the statement of first law of thermodynamics? What concept we are going to understand here with the help of first law? So, it states that heat energy absorbed by a system is equal to sum of increase in internal energy of the system and external work done by the system. So what is this heat energy absorbed? Expression is given by delta Q, which is equal to the sum of increase in internal energy, that is delta U, plus external work done, that is delta W. Here Q is nothing but the term which is used to explain the concept of heat. So delta Q is nothing but the change in heat energy, so which is equal to sum of internal energy and work done. So this is the first law of thermodynamics. You can easily remember the statement by just remembering the expression. So yeah, we have the explanation here, that is delta Q is the amount of heat absorbed by a system from the surrounding, and the delta U is the increase in internal energy of the system, and delta W is the work done by the system. Then according to first law of thermodynamics, delta Q is equal to delta U plus delta W. So the expression is very important. You can also expect this in the statement, can be asked for 1 mark in your examination. So next, what is this delta U depends on? Delta U is nothing but the internal energy. So it depends on the initial and final states of the system, and it doesn't depend on the path taken to arrive at that state. And delta Q and delta W, that is the change in heat energy or the work done, depends on the path taken to go from initial and final states, where delta U is independent on the initial and final states of the system. And the significance of first law of thermodynamics. What is the importance of this first law of thermodynamics? So it says about the law of conservation of energy, because from this expression we know heat energy supplied from surrounding to the system is utilized in 2 ways. One is to increase in internal energy, the rest of the energy is utilized in doing work, which means whatever the energy we are supplying is utilized in 2 ways, which is not getting wasted. So we can call this as conservation of energy. So the importance or the significance of first law of thermodynamics is conservation of energy. So in this session we have discussed about the terms which are involved in the study of thermodynamics, the importance of the chapter thermodynamics, basic laws that involved in the thermodynamics such as zeroth law and first law of thermodynamics and their significances. In upcoming session we will discuss more about this chapter, and we will learn more concepts about thermodynamics and the importance of this chapter. Until then, keep learning all of you. Thank you.